Let's talk about improper fractions and mixed numbers. These two things can easily be transposed between each other. You can take a fraction like 3 halves, and eventually you're going to get to where you have 1 1/2, which is 1 whole and 1/2 left over. Here's how this looks. If you draw a box and you make halves, you have 1/2, 1/2. That means you have 1 out of 2 pieces, 1 out of 2 pieces, except in this fraction, we're looking for 3 halves. So we're going to draw a third box. Now you have 3 boxes of 1/2. 1, 2, 3. When you put these together or add them together, 1/2 and 1/2 becomes 1 whole. And you still have 1/2 left over. Okay? So a way that you could also look at this is that a fraction is nothing more than a fancy division problem. You're going to divide your numerator by your denominator. So in this case, you're going to have 3, you're going to divide it by 2. We looked at how to divide fractions in one of the earlier videos. So in this case, we're going to look and we're going to see that 2 goes into 3 one time. 1 times 2 is 2. You subtract, you have 1 left over. I don't want to have any remainders. So what I can do is I can put a decimal point in here, which still says that I have 3. And I'm going to bring it up to the top automatically. That way I can just kind of ignore it. And I'm going to put a 0 behind it. Okay? When I do that, I'm going to bring it down. Now I have 10 down here. 10 can be divided by 2 5 times. So 5 times 2 is 10. You subtract, there's nothing left over, and that's the end of the problem. But what you see, as we looked at in an earlier video, 1 and 5/10 is the same thing as 1 and 1/2. These two numbers are interchangeable. They're the same thing. Whether you're looking at fractions or at decimals, it doesn't matter either way. We can look at a little bit more complex one. So let's look at something like 5/3. Okay? We're going to look at this the same way. So I'm going to make a box, and I'm breaking it into 3 parts because that is my denominator. So I have 1/3, I have 1/3, I have 1/3, except that I need to have 5 of them. So I'm going to draw a second box, and I'm going to make 2 more thirds. Well, if I have 1 out of 3 pieces here, 2 out of 3 pieces, 3 out of 3 pieces, 3 out of 3 is a whole. Okay? Now, I also have 1 out of 3 pieces and 2 out of 3 pieces more. Okay? So I have 2 out of 3. If you combine these together, you have 1 and 2/3. All right? So if you want to look at this in the realm of division, okay, you have 5, which is your numerator, divided by your denominator, which is 3. 3 is going to go into 5 one time. 1 times 3 is 3. You subtract. You have 2 left over. I don't want to have a remainder if I don't have to, so I'm going to put my decimal and my 0 in, and then I'm going to bring down my 0. Now, when I do that, I have 20. So 3 goes to 20 8 times. 8 times 3. I'm sorry. How about 6 times? 6 times 3 is 18, and I have 2 left over. Okay? So I put another 0 in, and I bring it down, and I put it in there. I don't need to add a decimal again because I already have one. So now I have 5 ones, I have no tenths and no 1/100ths, but it keeps our division problem going. So in this case, I'm right back at 20. We already know that 6 times 3 is 18. And what you're going to start to see is a pattern. It's not changing. We had 20, we subtracted 18, had 2 left over. We brought a 0 down, added it to the 2, so we have 20. We have 6 times 3 is 18, 2. So this is called a repeating decimal. It means that it's never ever going to change. It's going to go forever and ever. We can make a mark on this by putting a line above the 2 6s up here. So in essence, anytime that you see the decimal of 66 1/100ths, then you can automatically assume that it is the same thing as 2/3. Okay? They're going to be equivalent. They're going to be the same thing. Now, we looked at how to make an improper fraction look in or transfer into a mixed number. So what happens if we take a mixed number like 3 3/4 and we want to make it an improper fraction? How are we going to accomplish this? Well, it's actually quite simple. We're going to simply work a process, okay? You are going to, let's make this a little bigger, okay? You are going to multiply your whole number times your denominator. So in this case, we have 3 times 4, which equals 12, okay? Then you're going to come up and you're going to add your numerator. So we're going to add 3 more, okay? Which is going to be 15. Now, we have to look at what our denominator was, which is 4, okay? And we're not going to forget that we're talking about whatever we have is going to be divided into fourths, okay? So I have 15 fourths is the same as 3 3/4. How can we verify this? You do it backwards, okay? So you take your 15, you divide it by 4, okay? 4 is going to go into 15 3 times because 3 times 4 is 12, okay? 15 minus 12 is 3. Put our decimal in. We'll put our decimal on top. Or, well, and we'll put a 0 behind. Bring it down. And we'll go with 30. 4 is going to go into 30 7 times. 7 times 4 is 28. Subtract, you have a 2. Okay? So we're not done. We still have a remainder, and it changed, so we're going to continue to go. So we're going to add another 0. We're going to bring it down. 4 is going to go into 20 5 times. 5 times 4 is 20. I subtract. I have nothing left over. So it's going to show me that 3 75/100 is the same as 15 over 4. Now, if you want to stop a little short of that, here's the other way that this is going to work. You take your 15. We're going to divide it by 4. We already said that 4 goes into 15 3 times. Because when you multiply them together, you get 12. 15 minus 12 is 3. Now, we could stop here and realize that we can write our remainder as a fraction. So we have 3 whole times and 3 left over out of 4 pieces. So if you look, this, and that are all exactly the same. And this works in any case for every mixed number. It doesn't matter how big or how small it may be. So let's try one with 2 digits. I have 15, and let's do 1/3. Okay? So again, we're going to come back up and we're going to look at what our process is. We're going to multiply our whole number times our denominator. So I have 15 times 3, which is going to equal 45. And then I'm going to add my numerator. So plus 1 is going to be 46. Now, what was my denominator? That's right, it's thirds. Okay? So let's check. Okay? Remember, any mathematical process we use is also going to have an inverse operation. Inverse meaning opposite. So we're going to take 46, we're going to divide it by 3. Okay? 3 is going to go into 4 one time. So 1 times 3 is 3. We subtract, we have 1 left over. Bring down your 6, just like we've done in multiplication with whole numbers and decimals. 3 is going to go into 16 5 times. 5 times 3 is 15. You subtract, you have 1 left over. Now, just as we did up here, I can write my remainder as a fraction, and I have 15 1/3. We could also do this in decimals. And again, anytime you're talking about 1/3 or 2/3 as we saw before, you're going to have a repeating decimal, which can be a little intimidating. So in this case, I'm going to expect that we can leave this as a fraction, as a whole number with a fraction or a mixed fraction. Or we could be looking for the improper fraction, which means your numerator is larger than your denominator.